Fantastic interview. I really enjoyed that. I think it's really important to have a perspective. I mean, EDP are obviously one of the biggest providers in Europe, actually, and they sort of cover Portugal and sort of, I think, majority parts of Spain as well. So really good to get those views on energy transition and hydrogen in particular, and technology innovation as well. We now are moving on to our third panel of the day, which is focusing very much on actually what Miguel talked about, energy storage technologies, which is a bit of a conundrum. So overcoming the high capacity, long duration energy conundrum. It's moderated by the very charismatic Dave Hartell. So over to you, Dave.
Thanks very much, Adam. It's great to be back, and once again, really great participants and speakers. Always learn a lot at your conferences. So we've got a good panel here, very diverse group of people with different perspectives, but the topic of energy storage technologies is important. As we've increased the penetration of renewables, like solar and wind, people have fortunately begun to understand that these intermittent renewables need support from energy storage, and it's not just 4 hours of support. It might be 100 hours. It might even be seasonal, depending on the nature of the renewable energy. So it's important. There's various technologies available, and we'll talk about some various aspects of that. So I wanted to bring in the panel. The first speaker that's going to introduce himself and is Philip Steele, Future Technologies Evangelist, Octopus Energy. And I'm asking him about some of the risks and mitigations that we might face with these large energy storage technologies. Philip?
Yep. Good afternoon, David. Thank you. It's a pleasure to be on here. So yes, that is a bit of a title, the Future Technologies Evangelist. What that means is I look after a lot of our R&D side of things. So whether we're looking at what's going on with battery solar storage systems, what we're doing with electric vehicle charging, vehicle to grid, energy breakdown analysis from smart meter, what we're doing with smart tariffs and all that area. It's interesting, actually, the topic of risk with batteries. I think, some of the technology is evolving fast. And so in terms of what you put into people's homes or you're using with grid-scale batteries, you've got to keep an eye on those devices that are being manufactured to quality standards, that the installation processes are all correct and so on. With domestic, it's about things like MCS, microgeneration certification scheme certificates, and the correct notifications to the DNOs of the safe installation of those appliances and how they're going to work. And then some level of maintenance and monitoring of them to ensure that they are safely operating and doing what they are supposed to be doing.
Okay, good. Next speaker we have is Kevin Reeves, Industry Executive for Energy and Utilities, Microsoft. Kevin.
Yeah, thanks, David, and good afternoon, everyone. I hope you're well. Yes, I'm Industry Director for Energy and Utilities for Microsoft UK. It's very much a market-making role, so leaning into the energy transition and exploring how we can use Microsoft technologies to help achieve the outcomes that the industry has. I'd kind of pick up actually on what Philip had just said there, in that picking on the subject of batteries and thermal runaway. There's a lot we can do using sensing technologies to be able to detect ahead of time there's going to be an issue with that potential battery. If you're using lithium ion as an example, you can detect some of the off gases or unusual rises in temperatures to give you some foresight that there might be an issue with that battery. It allows you then to go and replace it or carry out maintenance to make sure that it doesn't turn into a fire. So I think there's ways in which we can use technology wisely to really help make storage solutions much more robust, much more secure, and more safe.
Yeah, that's great. Thanks, Kevin. Next speaker is Charlotte Johnson, Chief of Staff, KrakenFlex, a part of Octopus Energy. Charlotte?
Yeah, hi, and thank you for inviting me to this. So just quickly, a little bit about what I do at KrakenFlex. I basically focus on really sort of unlocking the value of distributed energy assets across a range of markets. And those sort of markets are like the wholesale markets, the balancing markets, and ancillary services. Briefly on KrakenFlex, We were originally called Upside Energy. We were then acquired by Octopus Energy in 2020, and that's when we became part of the Octopus Energy group. And I think in terms of sort of the risks and mitigation techniques around batteries at the moment, what we're really seeing is making sure the right warranties are in place, making sure that you have the right chemistry. So different chemistries have their own kind of nuances around them. And then what's really, I guess, coming out to play at the moment in the market is around risks in the supply chain and getting projects live. So we see a lot of assets in the market at the moment where you need to make sure that the asset is designed and the site is specifically designed to be able to participate in, for example, the balancing market or the capacity market. And that tends to be the biggest risk that we're seeing.
Okay, great. Our next speaker, Tim Manandhar, lead smart grid technology engineer, UK Power Networks. Tim, I wanted to ask you, you've got an important power network to look after. We might have all sorts of distributed resources, energy storage in homes, behind the grid, in front of the grid. There might be grid scale storage. There's got to be risks. You got to manage the network, and you've got some technologies out there. How does that work? How do you view these kind of distributed energy storage systems?
Yeah, thanks, David. So firstly, about myself, I lead the team of smart grid technology engineers. For a traditional distribution network operator, it's quite a new role for us as a function, as well as for the industry as well. And as you mentioned, we were having challenges from early 2010, really, when the East Anglia of our network started getting full of capacity in terms of connecting renewable generation, particularly wind at the time. So we had to quickly come up with a solution that will enable our customers to connect. And we, since then, from 2010 on to now, we have now implemented what we used to call active network management system. It's really a technology-driven solution, but it's a power systems and technology mixed together that enables the generation to connect, because we always have latent capacity on our network. That's how we design our network, and we run our network with a lot of latent capacity, but we never use that. Now we are using those capacity in our network by being able to dynamically manage our generation, a bit like what our broadband provider does it at home when it becomes very congested. And in the time, it will throttle our broadband speed, but similar to that, we will also throttle in a way a bit of manage the export of our renewables or the particularly in this case a generation to our network. And for the context of the discussion, recently, over the last few years, the storage has become quite a hot topic, or for us in terms of connections. So there's a huge pipeline of battery storage in our network, and we've got a lot of constraints and lots of challenges that comes with the type of technology it is compared to wind or solar or any other synchronous generators. So there are, it's a new breed for us as to manage the network. Like answer your question, it's a new breed of technology that has a unique behavior that we don't necessarily fully understand. So we are trying to understand and working with likes of National Grid ESO, or Transmission Network System Operator, the transmission network operator, and NGET at the moment to come up with some smart solutions.
That's great. Marzia Zafar, Director of Sustainability and Energy Policy, Kaluza. Just on the general topic of energy storage technologies and some of the risks and mitigations that need to be factored in. I was wondering if you could introduce yourself and talk about that a little bit.
Sure. So my name is Marzia Zafar. I spent the first 20 years of my career in California working with one of the largest utility companies there, and then spent 10 years of that 20-year period with the California Public Utilities Commission setting policies and regulations around storage, around smart grid. At Kaluza, I usually, in the face of Kaluza a lot, and you may wonder why the Director of Sustainability and Energy Policy usually joins these sessions. It's mainly because I think Kaluza, wants to push the idea of sustainability as much as possible, and we want to be known for that. And one of the ways that we're looking at storage is, since long-term storage has evaded the industry for quite a while, where everybody's working on it, but until then, we are looking at vehicle to grid as a possible solution to storage. And if we can turn EVs into small storage resources, and earlier, a few years ago, we started, and we still are, I think, the first and largest installer of residential vehicle to grid. And what we found from that program is that first, customers get to save money. We found that customers who participated in that pilot saved between $400 to $800 pounds a year. So that's a huge incentive for the customer to participate and be able to shift load. And more importantly, one of the findings was that vehicle to grid technology can provide up to 10 kilowatt hours of load shifting ability. So that's small storage that we can offer, or V2G can offer. And so if one V2G offers 10 kilowatt hours of load shifting ability, imagine if there was 10 million of these electric vehicles or V2Gs that DNOs could utilize, and to making sure that the system is operating well. So we're definitely putting a lot of effort into making V2G work. And then, of course, earlier in this session, there was also talk about green hydrogen as a form of long-term storage, and that's a viable option. But all of the right now, the biggest risk to decarbonization is one of the biggest risks, I should say, is how do we bring cost-effective long-term storage to the table to be married with renewable energy.
Okay, thank you, Marzia. Yeah, I guess one of the biggest challenges before we even get around to talking about V2G is we have to get these vehicles to actually be affordable enough so more of our society can afford them. I think the 2030 deadline is a bit tough when only a small percentage of society can afford the vehicles that are on offer right now. So our next topic is hydrogen energy storage. So again, a little bit of overlap with the first question. Hydrogen has some risks. It's a little bit polemic about how the hydrogen was created. What color of hydrogen is it? Is it black, brown, blue, green, purple from nuclear, or turquoise from other ways? I'll hand over to Philip, and what you guys, how you might view hydrogen.
Yeah, I mean, hydrogen has uses in industrial transport. I think that's the focus for us. We have a hydrogen business. You can look it up, and that's the focus there. The amount of energy that is consumed, electricity, to convert to hydrogen doesn't make it feasible to use it as an alternative to gas. So for heating our homes and for cooking and so on. So we've got a strong focus on heat pumps and electrification of heating, and the government has got targets there of 600,000 heat pumps being installed by 2028 a year. We're at about 20 or 30,000 at the moment, because that is a much more efficient way of using electricity to heat our homes. You take a heat pump and you've got 300 or 400% efficiency. You can't get that out of any other technology. So hydrogen has a place, and it's more on that industrial transport.
Okay, thank you. Yeah, I guess similar to the cost challenge for EVs, we have a cost challenge for these heat pumps. Seen some really big numbers for heat pumps for home usage. Kevin,
we we shouldn't ignore the grants that are available from government. There's a £5,000 grant in the UK. We're getting the heat pump cost down to about 7,500. So that kind of 2.5 isn't far off the cost of a replacement gas boiler. What you can't tell, actually, you may think I'm sat in a house. I'm actually sat inside a research centre. This house is inside a laboratory. You might just be able to see outside the window is not a nice sunny day. It's the inside of a laboratory. And what we are doing here is investing in heat pump technology and engineers to achieve that heat pump rollout.
Yeah, no, that's good. No, I think many people may not necessarily be familiar with heat pumps, but the idea that air conditioners are air-to-air heat pumps, so people are familiar with that. So the ground source heat pumps are getting popular, but even aquifer heat pumps, groundwater heat pumps are all pretty exciting technologies.
David, can
Kevin.
I interject for a second?
Okay.
You mentioned cost, that the cost of technologies, whether it's the EV or whether it's hydrogen, that it's really expensive. And of course it is, because it's just coming into market, whether that's V2G, that awareness is coming into market. So the cost will be enormous, but it'll come down as you scale it, right? And I think that's where also government has a huge role to play, to whether that's creating policies around it, or creating mandates around it, or creating a vision around it, so then the market could respond to it. And I think we need to make sure that we have the regulators, the also government bodies, and the market playing together to make sure, and then at the end bringing that frictionless customer experience to the customer, so this could work. But I wouldn't be hopeless. Because the cost of heat pumps are high right now, or the cost of producing hydrogen is high right now. I'm hoping that in the next 5 to 10 years that should come down.
Yeah, thanks, Marzia. Yeah, I think scaling offers tremendous potential for cost reductions, unless we've got things like critical minerals involved with a particular technology, and we may not have the supply we need. Therefore, the cost won't necessarily come down. But certainly, we've seen a lot of cost reduction in solar and wind, and electrolyzers coming down, and batteries getting more efficient. So that's great. I wanted to get over to Kevin. Kevin, I believe Microsoft has actually used some hydrogen energy stuff for some data centers. I don't know if you're personally familiar with that, but what could you tell us about hydrogen as an energy storage system?
Yeah, I mean, in terms of the data centers, we're kind of exploring, various renewable technologies as part of our net zero journey. So we've made a commitment to be sort of carbon neutral by 2025 on our data centers, moving forward actually to being sort of carbon negative. So how can we take that knowledge, that learning, help industry at large kind of move forward? So hydrogen's a part of that, as is wind and solar as well. In terms of hydrogen storage, we are working with various organizations globally on an industrial clusters model. So another use for hydrogen is in heavy industries, which is a big focus for industrial clusters in the UK. If you look at Zero Carbon Humber as an example, you've got a good collaboration there of organizations coming together to actually think about the role of hydrogen within that region. So you've got British Steel, consume huge amounts of energy. They're a ripe candidate for the use of hydrogen. What's also interesting about the Humber region is, just off the coast, you've got some huge wind farms, and they're going to be massively expanded over the next kind of 8-10 years. And in discussions with National Grid, they're kind of saying, well, if we carry on with the model as it is now, we'll get to a stage where National Grid might have to pay, the wind farm operators to turn down their assets, during periods on the network when there's not enough demand. Well, maybe we could be using that excess generation to produce, green hydrogen instead, and storing that locally and using it in heavy industry, potentially for heavy goods vehicles and public transport as well. There's some good work in Aberdeen as well, looking at the use of hydrogen for public transport. So I think there's lots of different uses. I think there's a really strong play for matching renewables with electrolyzers to produce green hydrogen to really help us accelerate net zero. So I'm personally very positive about hydrogen. I think it's one of the technologies that will help us get there.
Yeah, great. Thank you, Kevin. Charlotte, what can you tell us about hydrogen energy storage? Does that intersect with any of the work that you're doing?
Yeah, I think that's a really interesting one. Before I go into the hydrogen storage, I think hydrogen does have a role to play. And if you look at National Grid's future energy scenarios, hydrogen does feature in each of the 4 scenarios, obviously to varying degrees in each one. I think very similar to what kind of Kevin and Phil have already touched on, in the sense that there are a few use cases for where hydrogen does make sense. Although as a first principle, I would go with electrification as much as possible. And then we look at basically trying to decarbonize the very hard to abate industries. So industries where hydrogen's already produced using fossil fuels, and then where there is basically significant potential to reduce emissions from that by using clean hydrogen. And then potentially some forms of transport where batteries just wouldn't be suitable at all. You obviously have a question around then how actually hydrogen is going to be produced, so whether it's blue or green or some of the other shades that you've kind of already alluded to. But on the storage point, I think, being perfectly honest, with lithium-ion batteries where they are today and the efficiencies of them, you're looking at sort of a round-trip efficiency of 90% with a lithium-ion battery, compared to hydrogen storage, which is significantly lower. So once you kind of account for the inefficiencies of that, and also the compression of the hydrogen to get it into some form of storage, and the expense of it, I don't really think it can compete with a lithium-ion battery for anything in the sort of 4 to 8 hour range. You'd really be looking at more kind of interseasonal storage potentially. So where we do have excess renewable generation, and can we basically utilize that, store it, and use it for security of supply in periods of low wind. But there's a big if there, because we're basically making an assumption that if we have excess renewable generation. So when we get to that point, I think the interseasonal storage of hydrogen could be an argument, but definitely within the short duration, sort of 1 to 8 hours, I don't personally feel like it could be able to compete with lithium ion, although happy to hear someone else's thoughts.
Well, it's always an emotive subject. Every day I have enjoyment watching people fight it out on LinkedIn. I think there's the people that really like hydrogen and the people that think it's bad. But the idea that most solar farms or wind farms that we design, because of the nature of intermittency, end up being specified larger than the nominal maximum power, and therefore based on real world demand curves, we've pretty much always seen periods of excess renewables that we're going to come talk to this a little bit later on the curtailment item when we get to number 4, but we have seen that. And so people are spending a lot of time on figuring out, I agree with you on the short duration versus long duration, but long duration hydrogen is intriguing, and we've not just storing that above the surface, we're looking at porous formations in the ground, end of life oil and gas reservoirs that can be used to store hydrogen. And so there's tens of thousands of oil and gas wells in Alberta, Canada, for example, that are potentially being considered for that, with very large wind and solar farms, and they need seasonal storage. And that's one of the ideas being considered. So, Tim, hydrogen energy storage on the network, do you think that's going to happen?
Well, so far we haven't got any customers with hydrogen energy storage, but I think we are hearing that is not in the pipeline, but that is part of the discussion. How much is that going to impact our part of the network? I'm not sure at this stage, but for us, I don't think it really gives a different challenges. Still, the challenge for us is to manage the electrical power side of things that comes in and out of our network. So yeah, we are basically monitoring at the moment, monitoring the industry, talking to our customers in a regular basis, and understanding if there are things that we need to do to to enable and facilitate this transition. And also, I think one other point to mention, perhaps we will talk about a bit later on, is we are looking at more on whole system outcomes, the whole system thinking. So it's not just about what we do currently as a regulatory arrangement in the UK. We are obviously only doing in distribution at the moment, but we are working very closely with the National Grid and other DNOs at the moment, and also the rest of the industry, and how we can create value for the end customers with the whole system thinking. And I guess hydrogen has a part to play to that for sure.
Okay, great. Thanks, Tim. Marzia,
Yes.
hydrogen energy storage. What do you guys think about that? Does that have a role?
I think I'll give you my personal thought. As a technology provider, we don't have an official Kaluza position on this. I think on a personal level, when I was at the World Energy Council, we looked at hydrogen a lot, and green hydrogen seems to definitely have a role to play. I would agree with Philip on this, on at least the industrial use of it. Until such time where the electrolyzers become less expensive, the transport of hydrogen from whether that's Australia or Chile or other parts of the world that have abundant sun and can produce green hydrogen, until that transport cost and mechanism becomes cost effective. It's a long road. And then there's also consumer awareness and consumer fear. We did a focus group, and people over, I think, 45 equated hydrogen with the hydrogen bomb, and people below 45 just discounted it. So there's a lot of obstacles around hydrogen, but that doesn't mean that we should shut it down and say this is a no-win game. I think diversity of supply is hugely important. I don't think that being 100% going 100% electrification is good for the security of supply. So I think for that reason, we should be looking at whether that's CCS, whether that's nuclear, whether that's green hydrogen. We need, as an industry, we need to have a diversity of supply.
Yeah, I totally agree with you. Our next topic is vehicle to grid. So we've touched on that a couple of times in the panels so far. A hot topic. We need to have sufficient grid connections. We need to have sufficient electrical vehicles, but it offers some interesting promise. Philip, what are you guys doing with V2G?
Yeah, so over the past couple of years, we've been running a research project called Powerloop. So Powerloop is the Wallbox vehicle to grid charger and Nissan Leaf cars, and we actually provided two different methods actually with customers on the incentive. So either a credit for making the car available to discharge for overnight periods, and then secondly, we followed up with an import and export tariff, as we pioneered export tariffs when the feed-in tariff scheme ended a couple of years ago as well. So those customers then will get paid for the actual energy that's exported to the grid. Now, since we started the Powerloop project, it has also been launched into the UKPN balancing mechanism. I think Charlotte might have a bit more information on that, so I'll leave maybe if Charlotte wants to talk about that a bit more. But what's really interesting about vehicle to grid, you've got a car that is the order of 50 plus kilowatt hours that's sat on your driveway, particularly overnight and evenings, and so that has the potential to provide a level of balancing against the grid with flexibility markets and so on, because we're seeing the grid changing to being so much more renewable, which means intermittency and distributed generation. I'll let Charlotte go into some of the more detail on some of the balancing mechanism flexibility market side of things as well, because that's her expertise.
it'll be interesting if you're charging your car and you pay X for the electricity, and then they want to get some electricity back and want to pay you Y. It'd be interesting if X equals Y, or if they're going to offer you a premium or a discount. So maybe we'll talk about that later. Kevin, Microsoft and V2G, is that cross intersect in any way?
Yeah, it definitely does, and actually, it's very aligned to what Tim was saying about that kind of systems level thinking. For us, it's about understanding the system in which EVs sit. As we move to an energy market that's supply led rather than demand led, we're going to need things like EVs. If it's sat there on the drive and we've got periods of overgeneration, we could be using those batteries as temporary storage, and then putting it back to the grid when it's needed. All of that fundamentally relies upon digital and data technologies to help that whole system interoperate. So it's a key area of focus for us, and going forwards, you can only see the role of digital and data growing in this space.
Yeah, it'll be interesting with only a certain percentage of the UK having driveways to park their car and plug in, whether we'll have sufficient numbers of street charge-ins, and whether people will be incentivized to plug in, whether they need to charge or not, because they want to then participate in the V2G system's benefits. Charlotte, what can you tell us?
Yeah, so I think just before kind of going into the V2G side of it, it's really important to clarify that we also have V1G, and there's a huge amount of benefit that both the system operator can get and also the customer can get from that, whether you're on sort of like a power loop tariff or what Octopus call now a new tariff that's called Intelligent Octopus, which is basically a managed tariff for EV drivers that allows them to essentially set preferences on an app for when they want the car ready by and what time they want it ready by. And then there's a whole optimization piece that basically happens in the background that's automated, and it runs an optimization and picks the cheapest time to essentially charge the car. On the V2G side, so that's V1G at the moment. On the V2G side of it, there's some really punchy projections out there on essentially how much V2G National Grid is projecting there's going to be in the future. I think they talk about sort of 35 gigawatts of installed capacity by 2050, which when you think about it is significantly higher than all the demand you kind of get on the system, peak demand in the summer and also overnight demand. So we're talking massive sort of volumes of V2G that people are predicting. But to actually get to that level where we have that, we really need some clear price signals and also a lot more V2G enabled cars and also charge points. So the two kind of barriers at the moment. On the price signals, Phil's kind of touched on, we're looking at the next level of kind of commercializing that kind of power loop project. And you can do that sort of at a transmission level or a distribution level. So at the distribution level, you've currently got those DSO services, so UKPM ones that Phil kind of talked about. And at the transmission level, you've got a market like the balancing mechanism. And I think what's really tricky at the moment is using that market to incentivize customers to invest in V2G equipment. Because really, although Power Loop is making great steps forward in terms of entering the balancing mechanism, it's all through an innovation path, which is kind of relying on derogations from grid to get the assets into the market. The reality is that you need real-time operational metering. So that's kind of 1 second readings that have to be sent to National Grid within a 5-second window period. Which is really, really challenging for these smaller assets. The whole market has been designed for sort of centralized, large generators that can meet those kind of stringent requirements or technical requirements. And it's not designed at the moment for domestic or distributed assets. So a real key point there is the BM is not easy to access. And it also only addresses a GSP group or constraints at a GSP level. So if we want to go that level below, we really need to look at kind of distribution pricing. So something like kind of a dynamic duos price that would then signal to a customer based on the area that you're living in. If you charge or discharge your car around these times, you'll get an incentive for doing so. So I think that the kind of key piece that I'm trying to get at is there needs to be huge kind of market reform that actually helps us get or unlock the value of this domestic flexibility for both the system operator, but also for the end consumer, so that they want to actually invest in V2G technologies. Otherwise, I think the majority of people would just go with V1G, because the benefit won't really be shared, if that makes sense.
Okay, great. Thanks. Tim, a lot of expectations on the power network to get power out to all these charging points that don't exist right now. And then, even the capacity of the local grids to then have that extra demand. Is the network going to be able to do its part on this?
Yeah, I hope so. Philip and Charlotte already talked about some of the trials that's happening, at least with UK Power Networks. The Power Loop, we have a project called Transpower that we have been running for a while, and that's with Power Loop. That's basically has given a lot of good results for us. I mean, again, going back to the bigger picture here, to answer your question, as part of the Rio ED2 submission in to Ofgem, as part of the price control for 2023 onwards, we have proposed an independent DSO, distribution system operator, to establish that can then focus on the system operation side of things. And as part of that, we will focus independently in a way than a DNO, and how we can create those opportunities, how we'll create, unlock new value chain, or facilitate new markets, and to roll out or accelerate those initiatives. So over the last few years, there has been a lot of innovation projects, Ofgem funded innovation projects that has really helped us to give a lot of insights. So, for example, we talked about Transpower, and there's a Shift project with smart charging. There's Optimized Prime project with Hitachi and Centrica, and also Royal Mail, where we looked at the fleet charging, smart charging, and as well as Active Response project, where we really focus in the HV and LV network, where we balance, try to shift the demand from one HV or a secondary substation to another substation dynamically by using smart devices on the network, and also interfacing with our smart system like Active Network Management, or DERMS. So, and also not just us, but there are lots of other projects out there run by our partner DNOs, or other DNOs in the UK, and as well in the industry, that has created a lot of knowledge over the years. I think the challenge would be for us is how quickly we are able to put that into practice, which we have done, because we are almost led by our customers. So if we have, challenges currently now, or over the next few years on a part of the network, or part of the channel, we are in a way focused on delivering those to our customers. So the distributed generation being one, storage is again now a hot topic, but also those type of things that we are trying to do, and the LV network, and also I think we talked about, as Charlotte mentioned, the operational imagery, having access to very granular data that we currently have from our own network, sub-second data, or second by second data, or at least not half-hour data. Those things will add value. We are also getting a lot of insight recently over the recent months, at least in the recent months, over the smart metering data, and also as you know, we have limitations with smart metering data to understand the network a bit more. So we have made an application to BASE to get a disaggregated data for 130 or customers for a trial. So we are doing our best, I guess, to see how we can unlock solutions in our network to address the constraints.
Okay, thank you. Marzia, you talked a little bit about this V2G before. Did you have any last points on that you want to add?
Yeah, I think one critical point is that I think with many other solutions, we as energy stakeholders can come amongst ourselves and come together and find solutions. But when it comes to V2G and V1G, we are dependent on individual consumers. And we have to find a way as technology providers, as suppliers, as policymakers to make them aware of what they have with their electric vehicle, or else we've just wasted that opportunity. So V1G is electric vehicle charging right now is definitely customers are becoming more and more aware of it. But V2G is on a completely different scale. That awareness is not there. That understanding is not there. There's a potential fear that somehow this is gonna ruin your battery. So if we're gonna make V2G part of the solution, customers, individual customers, have to be made comfortable, have to be made aware, and it has to be a frictionless experience. Today it is not. Having a V2G charger costs an enormous amount of money versus a V1G charger. I think it's like, I don't know, 5 to 10 times more, and you have to have that driveway, as you said, David. So there's obstacles in front of V2G. And I completely agree with Charlotte. I hate to agree with our fierce competitor, but I think she's right that let's not forget about V1G. V1G is right here today. It's reliable. It's understood. Let's not ignore that and look for this other new opportunity, because that new opportunity has other obstacles that we should continue to try to resolve without ignoring V1G.
Yeah, thank you. Yeah, I think out of this discussion, one thing that struck me is there's some very significant aspirations for this concept, but as we've recognized, there's a lot of obstacles in the way. First, the people have to get the cars in the first place. Secondly, they have to have the charging point, and I personally wasn't aware of the cost difference there. And then to get people incentivized to do that, and so unfortunately, we've seen a lot of government decisions made on aspirations, not based on facts, and so we may not ever reach this capacity. Hopefully, they can address some of these risks. Our next topic is reducing curtailment. Curtailment is a terrible problem for some large renewable resources in many parts of the world. The sun shines and all your solar farms in the middle of the day are on maximum, and the grid doesn't need that capacity, or all the wind's blowing really good and all your wind turbines are functioning and you've got a lot of excess capacity, either for demand or even in some cases for the grid. There's wind farms in the UK which are constrained by the grid. They can't get out all their electricity. So it's a hot topic. Philip, how are you guys going to help reduce curtailment?
Well, there's a kind of a controversial as well as a regular answer to that question. A controversial answer could be, actually, if we keep building lots of renewable energy, each kilowatt hour that you generate from renewable sources is free energy. So what if it gets curtailed? But of course, we don't really want to curtail that when we've still got really high amounts of gas generation. I was looking at the data today, actually, and we're kind of around 60% of, I'm looking, this is the southern area I was looking at, is generated from gas generation, and we're at about 25% solar, because despite this laboratory, it is actually a really beautiful sunny day outside. Some of the things that we have done, though, and that we kind of want to expand on, is a tariff called Fan Club. So this is engaging consumers in changing their energy consumption according to how energy is being generated. We launched it with 2 wind generators, one in South Wales and one in North Yorkshire. And customers that live in the local postcode get a 20% discount when the turbine is turning, and they'll get a 50% discount when it's exceeding a certain wind speed on average in a half hour. And so we take the half-hour generation data, consumption data from meters, crunch the figures, and give customers those discounts. And then on top of that, we've launched a scheme called Plots for Kilowatts and Community Power to try and encourage more renewable generation to be built and to engage communities in that generation by actually saying, I really want that. It's kind of the matchmaking of the energy industry is what we've created after that. Because we need that renewable energy. And to us, it's more about let's build more renewable energy and get it used locally and get customers engaged in it.
Okay, thanks, Philip. Yeah, I agree with you. The marginal cost of incremental renewable energy is essentially free because it already exists. But if you're an investor and you've sunk capital and you're expecting a return on that capital for the cost of that facility, then a curtailment is a lost revenue and therefore it's lost value for that guys. Kevin, curtailment. How can Microsoft help with reducing curtailment? You're muted. Still muted. Nope. Let's Charlotte, I'll jump over to you. Reducing curtailment then. We heard some good things from Philip. Can you add something there?
Yeah, so I think just on that, briefly, like we really need to look at why we're curtailing renewable energy. So I think that there's been lots of articles in the press at the moment about how curtailment costs have jumped over the past year from sort of 200 million to 500 million. But when you really dig into that, you can then start to see sort of what's actually going on. So 20% of the curtailment costs are actually from curtailing the wind, whereas the other 80% is then ramping up gas assets somewhere else in the country. So that's where most of the cost is coming from. And you then start to look at BMRS, which is National Grid Balancing Mechanism and reporting service, which then tells you that all of those actions are system flagged, which means everything is constraint driven. So the real problem that we're having at the moment is how can we sort of replace all of that gas flexibility that we're ramping up when we have constraints with orchestrating huge portfolios of sort of electric vehicles, demand side response, and batteries. And I think on the duration note, when you look at those kind of curtailment periods, they tend to be for quite short durations. So we've got the technology already available to do that. Like we can use short duration batteries, and we can also scale up EVs and DSR. So for example, like if you took a portfolio of EVs, you could intelligently charge and discharge them depending on where they are in the country and create kind of like a virtual sort of balancing against that constraint that you've got. I still think we're going to need long duration energy storage or some form of long duration energy storage for when you've got periods of virtually sort of no wind or very low wind. And we obviously saw that back last year in September. I don't know if people remember when we had the very first time of sort of extreme pricing of around £2,000, £3,000 per megawatt hour on the day ahead market and £4,000 on the balancing mechanism market. And all of that was driven by sort of low availability of nuclear plants, low availability of interconnectors, and significantly low wind. So for periods of that, we'll always need long duration storage. But I think on the reducing the renewable energy curtailment, it's really about looking at where it's coming from and why we're doing it, and then what technologies we can try to use to plug the gap. And the reliability on gas flexibility assets is obviously a huge one.
Okay, thanks. Kevin, back to you.
Yeah, amazing the power of the hit the refresh button, isn't it, on the browser? Yeah, so this is a really significant area of interest for Microsoft. If you think about smart demand management at industrial scale, this already happens. At peak periods in the day, big industrial assets are turned off, or they can be ramped down, ramped up, depending on what the load is like on the grid. So that grid balancing at industrial scale happens today. It happens right now. What's interesting going forward is, can that technology be scaled across domestic markets? We're talking about the use of vehicle to grid as an example. Well, that might also apply to smart home devices. Your fridge doesn't need to be on all of the time. It can sort of intermittently be turned on and off and still maintain the temperature. So I think in the future, we're convinced we're going to see much smarter demand side management to help effectively flex and meet the available generation depending on what's available from renewable sources. So we've got to think about both sides of that same coin. We've got to think about supply and demand and making sure those two things match.
Maybe we'll get a discount from Netflix if we wait an hour to start our movie on the television in the evening at the peak time. Tim, energy curtailments. I guess you guys see this and fight this all the time.
Yeah. So curtailment has been it's quite close to my heart. I've been involved with curtailment, so to speak, almost 10 years now since we started the active network management project in 2012. So that's when I got involved with smart grid side of things in the business. And it's interesting to hear all the different views around curtailment and from the other panelists as well. So, to start with, I would say, for at least in context of connecting generation to the network, curtailment is one of the enablers. I mean, it might sound quite contentious, but without curtailment, we would not be able to allow the generation or the customers to connect to our network. So the fact that there is a flexible connection where we're allowed to curtail enables the additional distributed energy resources to connect. So that's definitely a starting point. So over the last 10 years, a lot of hours and days have invested in trying to reduce curtailment. It is a big problem for us. Obviously, we don't want to curtail our customers. Obviously, they lose money to start with, and obviously, it's not helping net zero at all. But we have a challenge we have a license condition we have to fulfill to secure the network, keeping the lights on. So there has to be a way where we have to keep the generation flowing, then power flowing to our network, but being able to manage our license condition, manage our network as well. So there are different sides to it, I guess. Obviously, we talk about digitalization and technology here. We have been investing a lot of time and efforts over the years trying to improve the technology we started with in 2012, the initial innovation project, to where we are now. So it has gone a lot more intelligent in the way how it optimizes, how it analyzes, and how it manages overall the curtailment side of things. And we have also one innovation project called Constellation that is also looking at distributed intelligence, i.e., digital substations in the grid, which then be able to, it's running at the moment, so which will be able to detect the electrical signature of the network rather than waiting for the central intelligence system to tell us or tell the devices on the substation to either curtail or not curtail, but able to detect it by the electrical signature. We're going back to basic principles, and it buys us more time so that we don't curtail the generation, and we hope that the central system, the link to the central system, gets restored. So there are things that we are doing to try and mitigate the curtailment scenarios, or try to reduce, try to shift back as much as possible, and it involves real optimization, looking at in the technology scale, looking at the little timers of the various parts of the system. So we have got a communication system, we have a central system, we have the distributed systems in our network, like remote terminated RTUs, or the devices that actually control the generators. So there is ongoing work. It's not finished. We will continue to put our efforts in reducing curtailment for the customers who are already in our network and are already exporting. What also important, I guess, for us, so over the last month or so. In May, Ofgem has made a final decision on the access charging. So that gives a clear indication of what we need to do going forward. Obviously, there is a bit of a working group and all that happening to understand, to establish how that's actually going to be implemented. But there is a method where there will be a cap threshold as well on the curtailment, and we will have to perhaps look at other options like flexibility services to manage curtailments. So yeah, I think there are quite a lot of things happening.
Okay, thanks. Hey, unfortunately we're running out of time, and so we're going to skip the last topic and just get a final statement from each of you, if I could. So very quick, about 8 minutes left. Marzia.
I will say this as my last comment. Tim mentioned at the very last that, well, if we exhaust everything else, we'll look at flexibility. I hope that we can change that. I hope us and the rest of the people who are providing flexibility, I hope we can change your mind on that. That domestic flexibility can become a first option.
Okay, Philip.
Our topic, actually, I was just looking at the topic for the wrap up, and our topic was around energy storage technologies. And although we talked more about high capacity, long duration a little bit, and did a side diversion into hydrogen and things, actually, when I was describing with the fan club tariff and some of the things around renewable energy, we're going to have a kind of a grid that's much more distributed with its generation and much more variable when that is generated. And so storage kind of takes a really big play in all of that. But actually, we shouldn't constrain ourselves to thinking of storage as just a battery or generating a bit of hydrogen. And in fact, I'll bang on about heat pumps because I love heat pumps. A heat pump is an energy generator. It is consuming energy, a kilowatt or 2 kilowatts, but it is generating 3 to 4 times as much energy as it's consuming, and it has a storage element, either such as a hot water tank, and so that has a role to play as well. So as we talked about cars as a storage of energy and so there are quite a few different ways in which you can store energy, and it's the mixture of all of those and how that's all managed which starts to get really interesting in how we kind of move to this future smart grid.
Yeah, that's good. I think sometimes people focus on electrical energy and they forget how important heat energy is. And well, I guess the opposite of heat energy, cooling. Kevin, sort of final statement.
Yeah, I mean, for me, it's to recognise that energy is the lifeblood of a modern economy. I mean, our business is entirely dependent on it, as are most other sectors. So, I think we really need to think about the value that energy provides to the economy as a whole when we're thinking about the business case for some of these new technologies and approaches. I think we often miss that, and it's vitally important that we get that right, because economic growth is tied to security of supply in the energy market.
Okay, great. Thank you. Charlotte, final comment.
Yeah, so I think really, like, according to, again, National Grid's future energy scenarios, 50% of the flexibility in 2050 is going to come from, or should come from, domestic consumers. So that's around 80 gigawatts. So we really need to find a way of unlocking that at scale as soon as possible. And that's really going to kind of involve market reform and really updating some of the old grid codes and frameworks that we've got in place and are just not suitable for smaller assets.
Yeah, a lot of challenges, but fortunately, we've got a lot of smart people working on it, like on this panel. Tim, final comment.
I would say my final comment along the lines, I think we'll address Marzia's concerns. I have been talking about what we have been doing over the last 10 years, really going forward. The forward-looking strategy, or the strategy is forward-looking, the forward-looking plan for us is flexibility. We are going flexibility first. So that has the whole point of setting up independent DSO, that we rather going away from asset-based solution to flexibility-based solution. I think it will take a little bit of time to use and really tap into the flexibility from domestic and LV, but we have got, I think that, as you mentioned, smart people, smart projects, and a lot of initiatives happening. Hopefully we can accelerate those over the coming years.
Do you see good support from the government for this? I mean, are technical people being allowed to get on with this, or are we still challenged to educate the politicians?
Yeah, I think it's both ways. I think smart metering I mentioned earlier is a good example. The enabling. We have the data, but we are not allowed to use it, or we don't are allowed to make have the full visibility. So those things like that would help. Having visibility, have data, we always unlock lots of benefits. So I think those areas, I think we definitely need more focus from government or from the authorities.
Okay, great. Yeah, it's fascinating. We have lots of technical solutions, lots of technical challenges. We have very good software systems, computer systems to try to match all this. It'll be very interesting to see how this plays out. So today's panel, I want to thank you very much. The nominal topic was energy storage technologies, but it's hard to separate that from everything else. What is the energy source? Why are you trying to store it? What's the constraints, the curtailment reasons, the variable? How can we make use of some assets like these increasing numbers of EVs? So, what role can they serve, and do we have the necessary infrastructure to connect them all in? And working with people, incentivizing people. What's the commercial system? Do we offer them discounts? Do we offer them payments? How that all works, and educating people, and can we come up with software systems that will help make some of those choices so that people aren't getting text messages on the phone? Do you want to turn down your refrigerator right now? I will offer you 5-cent discount on your kilowatt hour for the next hour if you can turn your refrigerator off. Will AI systems come in to help us with that? That's going to be fascinating. So, very complicated world, but hopefully we're making progress there. So thanks again to all the panelists. And I'd like to hand back to Adam, if I could.
Thank you, everyone. I love that comment, actually, Dave, because, yeah, imagine if you were getting text messages about, putting your fridge off or putting something off and you'll get a discount. I think it's an interesting comment, and it's going to be really eye-opening when they, let's say, incorporate technology into how you monitor these consumer patterns and how they manage it. We have the final panel of the day, which is coming up, I think, at 20 to 3, is actually on that. So we're talking a lot about AI and machine learning, IoT, and how that works with the consumer. So that's a good finish to the panel. Really, really interesting about the vehicle to grid and how all of this changes are sort of being made now. It's really good to get Tim's perspective as a network operator on that panel, because you had obviously mainly tech involved companies, but it was good to get Tim's point of view on. It was like sort of the tech were asking, but then the utility was saying, well, we could do that, we could not do that. And obviously it's dependent on policy as well. Again, how much of that discussion was sort of geared around policy and government policy, and how to also incentivize the consumer, because I think everyone would probably turn green or would sort of go down this route if there was a really strong incentive to actually to get everyone to do it, financial incentive to do it as well. I think you're going to have to do that to change patterns of behavior. We're used to working and operating our electricity and our heating in a very specific way, and I think that needs to change quite quickly. But the way we change it is not to just say we have to change it. You have to give ways in which we can change it and incentivize that. So really good discussion. I like obviously what Kevin said about the supply led. It is supply led, not demand led at the moment, and I think that's one of the issues we have. And obviously building, I think Marzia mentioned about consumer awareness. There's consumer fear as well, so that's something to take in consideration, I think, when working on these plans. But a brilliant panel, really enjoyed it. Fantastically put together by Dave Hartell as well.